Hello everyone and welcome back to MV Tutors, and we're having a look now at the maths paper written last year in November, paper 2. We've done paper 1 already, and let's check out what paper 2 has in store for us. Please don't forget to like our videos and as well as subscribe to our channel, and do let your friends know about our channel. Because sharing is caring, hey? Don't keep the knowledge to yourself. Alright, so let us begin with question 1. Alright, so it says, truck drivers travel a certain distance and have a rest before traveling further. A driver kept record of the distance he traveled in kilometers on 8 trips and the amount of time he rested in minutes before he continued his journey. The information is given in the table below. Alright, so if we were to put this in a graph, on the x-axis, the independent variable, you'd have the distance traveled, and the amount of time or the amount of rest time really depends on the distance traveled. So the y-axis, that would be your dependent variable. All right, now question 1.1 says, determine the equation of the least squares regression line for the data. Okay, that equation, you also find it in your formula sheet, would be y is equal to bx. Quite similar to y is equal to mx plus c, but instead of m we have b, instead of c we have a. Okay, now firstly let's input this information into the calculator. If you're using a sharp calculator, just go mode, and I think it's option 3 on the Casio calculator, so you choose stats, and over here we're looking for a plus bx now. Because we don't have a single variable, we have bivariate data. So a plus bx, and we're going to input all this information. Okay. Yeah, let me do this. All right. So, okay, now what happened? Let me just do this mode, get back again. A plus bx. Okay, we're going to put in 180, 200, 400, 600, 170, 350, 270, 300. All right, so that's the x. Now let's go to y. Here it's very important not to put in the incorrect information, or else everything becomes incorrect. So just make sure in this stage you are inputting the correct information. Double check if you have to. Okay. All right. And once you're here, you can just click AC and then shift stat. And then what we want, the regression, right? Regression calculate. So for the Casio, it's a little bit different. It will not give you the information like this. You need to go click A, then you get the answer for A, B, you get the answer for B, and R as well, which is the correlation coefficient. But here, this calculator summarizes it quite nicely. So I can then input the information. For A, I have negative 23. I'm going to round off to 2 decimal places. Or maybe let's make it 3. So 846, and then plus 0,227x. So that is our formula. All right, and then I'm just going to put R there, just, for control, just in case I need it. They didn't ask for it. Okay, and then 1.2, it says, if a truck driver traveled 550 kilometers, predict the amount of time in minutes that he should rest before continuing his journey. Remember, the amount of rest time is y, right? And what they've told us is the distance traveled, which is x, okay, 550. So I'm going to take my equation, minus 23,846 plus 0,227. I'm going to multiply it by 550. So let's just take our calculators. You can go back to the normal mode, or you can still do the calculations using the statistics mode. It's really up to you. But yeah, I prefer going to the normal mode and multiply it by 550. So we get 101. Let's see. Yeah, negative 23,846 plus 0,227 times 550, and we get 101,004. I'm just going to leave it at 101, and this is minutes. Okay, minutes. If you had rounded off to 2 decimal places, you would have gotten negative 23,85 plus 0,23. So you would have gotten slightly different answer. But I don't think they would be that strict. I think they would provide a range of answers that they would accept. Okay, so you would get 102,65 minutes. So it depends on your accuracy. Rounding up to 3 decimal places or 2. Okay, so that's 1.2. So far, so good. 1.3, it says write down the correlation coefficient. Okay, we did write it somewhere up there. 0,983. Maybe let me round up to 2 decimal places. 0,98. And then it says interpret your answer for 1.4. To question 1.3. So this is a very strong positive correlation, okay, of the distance traveled and the rest time. All right, so it's very close to 1, and if that's the case, you would say it's a very strong positive, okay, because some of them are negative. So this is a very strong positive correlation. I don't think you need to write anything more. It's just 1 mark. And then 1.5, it says at each stop, the truck driver spent money buying food and other refreshments. The amount spent in rands is given in the table below. All right, so we now have, we don't have bivariate data. We just have single variable, 100, 150, and so forth. Now it says calculate the mean amount of money he spent at each stop. The mean, please don't calculate this by hand. Use the calculator. So we're going to go again, mode, stat, and now we have single variable. Okay, so we can then write or put into the calculator the information. By the way, it's very important to take breaks while driving because we have heard about so many accidents happening on the road, especially with truck drivers. And while you're at it, do get some snacks. Okay, so that's the information, and now we can go shift stat, and we are looking for this calculator, ne? Okay, shift stat, single variable, calculate. Yeah, it gives you a summary. So we get there that it is 150, and this is in rands. Okay, so the mean amount of money spent is 150. You can see here on average, because that's what we're getting if we're calculating the mean. On average, it is around 150. All right, so 1,5,2. So 1,5,1, the answer that we got does make sense. Okay, and now it says calculate the standard deviation for the data. So standard deviation, it would be that sign. Okay, so in this case, the standard deviation would be this 5 root 102. Okay, wow, this calculator like gives you everything. Well, in the test, you won't have this kind of calculator. So we have 5 root 102, and I prefer let's just go back to the normal mode and figure out what this 5 root 102 actually is. Okay, so we have the answer there as 50,50. All right, that's the standard deviation. And then 1,53, that's the last question in question 1. It says, at how many stops did the driver spend an amount that was less than 1 standard deviation below the mean? Okay, so we know the standard deviation. Okay, there it is, 50 rand and 50 cents. So now what happens if we have less than 1 standard deviation? So what do you do there if it's less than 1? You would take your mean and you add, sorry, not add. If it's more than 1 standard deviation, you add, but this is less than 1 standard deviation, so you subtract. All right, and so you're going to get 150 minus 50 rand and 50 cents. Okay, so you're going to get, so 150 minus the answer, you're going to get 99 rand and 50 cents. Okay, but now we're not done. Remember, it says, at how many stops did the driver spend an amount that was less than 1 standard deviation? So the standard deviation, the 1 standard deviation below the mean is 99 rand 50. So anything less than that, we need to look for it from this table. And you can see that the only amount that is less than 99 rand is actually 50. Okay, so after how many stops? It was just 1 stop. If there were other values less than 99 rand 50, then it would be more than 1 stop. All right, and that's it for question 1. Question 2. At a certain school, the staff committee wanted to determine how many glasses of water the staff members drank during a school day. All teachers present on a specific day were interviewed. The information is shown in the table below. How many of you drink water? Water is very important, guys. Please do get your minimum or maximum of 8 glasses a day. But let's see. So this is the table there, and they show us how many glasses of water drank per day and the number of staff members that drink. So we can see most of them drink between 2 and 4 glasses. Maybe the other part of drinking goes to drinking coffee. I don't know. People love their coffee more than water. So it says 2.1, complete the cumulative frequency column provided in the table in the answer book. So we don't have the answer book with us at the moment, but I'm just going to just write out here. So now the cumulative frequency. All right, so we have 5 initially, and if we add 15, we get to 20. Then we add 13, we get to 33. Adding 5 gives us 38, and adding 2 gives us 40. Okay, so this is what you would put. All right, and then 2.2, how many staff members were interviewed? All right, so the nice thing about doing the cumulative frequency is at the end, you can see the total amount. All right, so how many staff members were interviewed? 40 staff members. Alrighty. And then, how many staff members drank fewer than 6 glasses of water during a school day? Okay, you know what? It's nice when you have this information next to the table, okay? Because you can then see for this column over here. So let's just say, okay, it's not exactly, but we can sort of like put our information next to it. So we can see for, okay, how many staff members drank fewer than 6 glasses of water during a school day? So fewer than 6 glasses, that would be on the 3rd row, all right, where we have 13, and our cumulative frequency we have 33. So that is the answer that you would put there. Okay, so 33 staff members drank fewer than 6 glasses. That's a lot. 33 out of 40, that's like, that is a whole lot, more than 80%. Okay, just shows you don't really like drinking water as a people. Or is this reflective of teachers only? I don't know. Okay, and now 2.4. Alright, so it says the staff committee observed that K teachers were absent on the day of the interviews. It was found that half of these K teachers drank from 0 to fewer than 2. Okay, so let's just write it down as we read so that we do not forget. So in this region, half of these K teachers. All right. While the remainder of them drank from 4 to fewer than 6. Okay, so 4 to fewer than 6, that's the rest of them, which is the other half. Glasses of water per day. When these K teachers are included in the data, the estimated mean is 4 glasses of water per staff member per day. So we have our mean there as 4. Now, how many teachers were absent on the day of the interviews? Okay, these questions tend to be a little bit tricky, but with the information that was given, I would say just note the information that was given to you. Okay, first of all, they talk about the mean. And if they talk about the mean, I'm thinking now, let's just do the calculation for the mean. All right. And remember, when you have such with the cumulative frequency, especially with the range that they give you, when you calculate the mean, it's a special way in which we do it. I don't even know if they have an equation there in the formula sheet. Let me just have a look for how you calculate mean. Yeah, well, it's the normal way of calculating the mean, not necessarily when you're dealing with information like this, where you need to choose a median. Okay, so this is how you would calculate the mean. So the mean would be equal to, so you have your number of staff, right? So you just take your 5 and then multiply by the median of the information that's given. So between 0 and 2, you get 1, all right? And you continue calculating. But now, remember, between 0 and 2, there were half K teachers that were absent. So you can't just say 5 times 1. There's 5, but also 5 teachers plus that half K, okay? So please don't leave that out. So we have 5 plus half K, and you multiply it by the median between 0 and 2, which is 1. Okay. Ooh, I don't know if I'm going to have enough space, but let's see. And then you continue. Then you have 15, and you multiply by 3 because that's in between 2 and 4. Then we have 13, but remember, from the region of 4 to 6, there's still that other half K. So you would take your 13 plus half K and you multiply it by 5. All right, and then you have 5 multiplied by 7, and then you have 2 multiplied by 9. All right, and then all of that is divided by the total. So now the total number of staff members, remember, that is 40 plus the K teachers that were absent during that day. Okay, so that's very important to remember. Now they've given us the mean, which is 4, and I'm going to multiply it already with the denominator so that I just don't have to deal with fractions anymore. And then we have 5 times 1, which is just 5, and then half K times 1, that's just half K. 15 times 3, use the calculator if you have to, 45. 13 times 5, I'm not sure what that is. So yeah, 65. So I have 65 plus 5 times half K, that's just 5 over 2K. And then 5 times 7, that is 35. 2 times 9, that is 18. Okay, if I multiply the brackets out, 4 times 40, I'm expecting 160. And then 4 times K, that's 4K. Let me just simplify on the other side. So I have 5 plus 45. Just underline the similar numbers. So I have 5 plus 45 plus 65 plus 35 plus 18, and I get 168. Then I have half plus 2.5, which is 3. Okay, so 3k. Then I'm going to take the 3k to the left hand side. So now I have k remaining. And then let me just write it out nicely. Or let me just write it out fully. So I have 4k minus 3k. And I have 168 minus 160. So now k, I hope that you see, is actually equal to 8. So how many teachers were absent on the day of the interviews? 8 teachers were absent. I don't think it's necessary to write this down. Just saying k is equal to 8, that should be it. All right, and then we are done with question 2. Let us tackle question 3. So far, the paper is going well. So it says in the figure, so we have a right angled triangle. Okay, and what does it say? We have L, S, and N. They've given us the coordinates, and those are the vertices of a triangle having angle L as 90 degrees. And then LN intersects the x-axis at K, as we can see. All right, now, question 3.1. So it says, calculate the length of SL, all right, and leave your answer in third form. So here, we're really just going to use our distance formula. The coordinates are given, so this is pretty straightforward. Okay, so the distance or the length of SL. I'm just going to take the x-coordinate of S minus the x-coordinate of L, and we square it and do the same with the y-coordinate of S and L. And all of this is under a square root. Okay, so let's substitute. The x-coordinate of S is 4. That of L is minus 4, so that becomes a plus 4. Y-coordinate of S is 5, and that of L is 1. So we square that, put it under the square root. So 4 plus 4 is 8. 8 squared is 64. 5 minus 1 is 4. 4 squared is 16. And 64 plus 16, that should be 80, but let's just check. Yeah. So we have the square root of 80. Maybe we can simplify it further. Still insert form. But let's just see. So it's 4 root 5. So you can decide however way you want to put it. So that is the length, okay? And don't forget to put the units, especially if they didn't tell us the units. All right. 3.2 says calculate the gradient of Sn. Okay, so Sn, we can see that's the slanted, that's the hypotenuse. So gradient of Sn. Okay, so far they're asking basic questions. So Yn minus Ys. Please don't put x in the numerator. When you calculate gradient, it's y over x. Okay, and then xn minus xs. Okay, so the y-coordinate of n is minus 3. And that of s is 5. X-coordinate of n is minus 2. And that of s is 4. So minus 3 minus 5, that's minus 8. Minus 2 minus 4 is minus 6. So if I take the common factor between them, which is 2, I'm going to have 4 over 3. All right, because the negatives would cancel out. So that is the gradient. Now 3.3. How are the marks looking? Okay, 2 marks each so far. Alright, 3.3 says calculate the size of theta, the angle of inclination of Sn. That is, it's a good thing we calculated the gradient. So tan theta would be the gradient of Sn, which we just calculated. So if I want theta, that would be arctan, or the inverse of tan. And the gradient that we calculated was 4 over 3. So here, let's use the calculator. Make sure it's on degree, mode and not radians. So shift 10, 4/3, and we get the angle of 53,13 degrees. Okay, now 3.4. It says calculate the size of n, all right, in between L and S. So basically, we are looking for this angle over here. Well, for me, since we have a right angle triangle, in all honesty, let me just call this angle alpha. Since we have a right angle triangle and we calculated what? The length of SL. So SL, we have it as 4√5 units. It doesn't matter, I would calculate the length of LN, maybe the length of SN. All right, and then I can use, well, if I calculate SN, I can use sine, right? Sine of alpha would be SL over SN. Or if I want to use tan, I can calculate the length of LN. It doesn't matter, but I'm going to go ahead and calculate the length of SN. Okay, there are many ways of doing this. This is my way of doing it. All right, so let's calculate the length of SN. Do it rather quickly. Let's see how many marks. 3 marks. So you shouldn't be wasting time here. So the distance of SN, okay, x coordinate of S, or let me say x coordinate of N, which is -2, minus the x coordinate of S, which is 4 squared. I'm not even going to write the equation down. Y coordinate of N is -3, and then of S is 5, and that is squared, and all of that is under a square root. So I have -6 squared plus -8 squared. All right, and then that would be 36 plus 64, and that is 100 actually. So the square root of 100, that is 10 units. We're not done yet though. We want the angle of LNS. So I would say, all right, I would say sine alpha, but Jamalka needs to know what alpha is. Yeah, so sine alpha, or you should have just said, let LN S equal to alpha, so that you can guide the person who's marking your test. All right, so sine alpha is equal to SL over SN. All right, so alpha then in this case is arc sine, and SL, we found that to be 4√5. Forgot that I wrote it. 4√5, and SN is 10. Okay, we can just put it there, 10. Okay, cool. Now we can calculate. So shift sine, and then we have 4√5 all over 10. Okay, and that answer is 63,43 degrees. And that is your answer. And you can say that is actually LNS. Okay, great. We can also just put it there for ourselves and say, all right, that angle there, 63,43, just in case they want it somewhere. All right, so that was 3.4. Now 3.5. It says determine the equation of the line which passes through L and is parallel to SN. Write your answer in the form y is equal to mx plus c. Okay, that's quite interesting. So it's parallel to SN, passing through L. So if this is SN, it being parallel to it would be something like this. Okay. Now, whenever you want an equation of a line, you firstly need a gradient. Do we have a gradient of Sn? Yes, we did calculate it, and it was 4 over 3. Okay, have a gradient, 4 over 3. And do we have a point? Yes, we do. Okay, because they said it passes through point L. And once we have that, we can definitely get the equation of a line. So we're going to use y is equal to mx plus c. In the place of y, I'm just going to put 1. In the place of m, that's 4 over 3. X is negative 4 plus c. So if I work that out, I actually have negative 16 over 3 and 1 plus c. So c is equal to 1 plus 16 over 3. Okay, if I put 3 as the common factor, no, not common factor. If I'd make 3 the denominator, I would have 3 plus 16 over 8. Or you can just really use the calculator. But c is 19 over 3. Therefore, the equation in the form of y is equal to mx plus c, that's equal to y is equal to 4 over 3x plus 19 over 3. All right, that's 3.5. Now 3.6, calculate the area of triangle LSN. Okay, I'm just going to redraw LSN for us upright because the area of triangle LSN is equal to half base times height. And what is our base in this case? So we have SLN. Okay, our base is LN and our height is SL. Oh gosh, now do I need to go calculate the length of SL? No, I have it. We did calculate the length. Let me just, yes, it's 4 root 5. Great. And LN, do we have that length? No, we don't. So we probably have to go and calculate the length of LN. We can use Pythagoras actually to get LN. So we can say SN squared is equal to LN squared plus SL squared. So LN squared is SN squared minus SL squared. All right, do we know what LN is? No, that's what we're looking for. SN is 10, right? So 10 squared, that's 100. And then SL is 4 root 5. We just need to square that. Actually, it was root 80, remember, before we simplified it. So this is like root 80, all right? So if it's root 80 squared, that's just going to be 80. Ooh, why am I writing 800? Okay, so 100 minus 80, that is 20. And ln squared, we're going to just root both sides. So ln is root 20. All right, so we have everything that we need. We can then calculate now. All right, so the area of triangle LSN is half. The base is root 20. The height is SL, which is 10. No. Where is it? Root 80. Root 80. What am I saying? It is SN, that is 10. Okay, so let's go calculate. So we have 0.5 times root 20 times root 80. So we get 20 units squared, 20 squared units, however way you put it. Okay, so far so good, right? 3.7. Now it says, let's see the marks, 3 marks. Yeah, maybe they were a little bit stingy with the marks, or maybe we just did too much. All right, 3.7, calculate the coordinates of P, which is equidistant from L, S, and N. All right, so what do we say about this equidistant? So if it was any other, we have a right angle triangle, by the way. Okay, I'm just going to draw it. If it was just a random triangle, whenever you calculate equidistance means if I have a point P here, it means the distance here is the same. So x, that would also be the same, and that would also be the same. So that's equidistant. All right, that's if we have a normal or random triangle. But if you have a right angle triangle, what you normally do, okay, so let's just label it again, SLN. What you do, you take halfway of SL, all right, and you also take halfway of LN, all right, and it also meets halfway SN. So basically, this would be the equidistant point. So P would be somewhere there with a right angle triangle, all right. I hope I didn't lose you there. Okay, so now what we're going to do in order to get this equidistant point, and how many marks is that? 3 marks. So like I said, this that point is halfway, this point is halfway, P is halfway SN, which makes life a little bit easy for us. So we can say P is actually the midpoint of SN. So the midpoint of SN, that's just the coordinate of x coordinate of S, x coordinate of N, and we divide that by 2, y coordinate of S plus y coordinate of N, and we're going to divide that by 2. All right, that's how you're going to get the midpoint, and that would be your P. All right, so what is the x coordinate of S? That is 4. For N, that's minus 2 over 2. Y coordinate of S is 5. N is minus 3, and divide by 2. So the coordinate of P, 4 minus 2, that's 2. 2 divided by 2, that's 1. 5 minus 3, that's 2. 2 divided by 2, that is 1. So that is the coordinate of P. If you have time, really this is if you have time, go and see if the distance from S to P is actually equal to the distance from L to P, which is equal to the distance from N to P. Okay, that's if you have time. You can check that. They should be equal. If they are not equal, then we have problems. Okay, so let me see. This question is worth 20 marks. Remember how you can determine how long to spend on a question? You simply take the amount of the marks, or the amount of time, which is 3 hours. 3 hours is 180 minutes divided by 150 marks. So 1.2 minutes per question, or per mark rather. So 1,2 times 20 is 24. Where are we now? We are at 17. So I say we use the little time that we have to actually calculate the distance, just so that you are sure and you are actually certain that P, which has the coordinate of 1 and 1, is actually it's actually equidistant. Okay, so I'm going to get the distance of SP quickly. All right, and I'm going to take, okay, the x coordinate of P minus that of S, y coordinate of P minus that of S. Okay, so 1 minus 4, that's minus 3 squared, that's 9. 1 minus 5 is minus 4. Minus 4 squared, that's 16. And 9 plus 16 is 25. And root 25 is 5. Okay, so now distance of LP, 1 minus, I'm going to start with P. So P is 1 and L is minus 4. So I'm going to just add 4 there. And we have 1 minus 1. Okay, so we can see 1 minus 1, that's 0. 1 plus 4, that's 5. 5 squared, that's root 25, which is equal to 5. So far we're good. Now let's look at the last one, distance of NP. So P, which is 1, and N minus 2. All right, we have 1 minus 3. So 1 minus 2, that's just minus 1, that's just 1. And 1 minus 3. Oh no, what am I doing? It's 1 minus minus 2 and 1 minus minus 3. So we have 1 plus 2, which is 3. 3 squared is 9. And 1 plus 3, that's 4. 4 squared, that's 16. And that's 9 plus 16 is 25. Root 25 is 5 units. So we've checked the coordinates of P, which is 1 and 1, is actually correct. So we can move on with confidence. All right, and then the last question says, calculate the size of LPS. Okay, 3.8. I'm just going to redraw this again. Okay, so that's S, that's L, and that's N. And we say halfway SN, that's P. So they want the angle P in between L and S. So if I were to take a line, so from L to P, we know that's 5 units. And then from S to P, we also know that's 5 units. SL, that's root 80. Okay, but we actually have an isosceles triangle. All right, so what do they want? They want the angle P. Okay, I'm going to call that beta. All right, what do we have? We have all the lengths. We're just looking for angle beta at this point in time. Alrighty, yeah, what can be our method of determining that? What angle can we get? We can get angle S, right? Because we have N. Remember, N is 63,43. And if we have N, we can get S. Okay, so let me just say L, S, N is actually equal to 180. And this is what? Only 2 marks. I'm definitely going to do a lot than 2 marks. So it's basically 180 minus 90 minus 63,43. And that's sum of angles in a triangle is equal to 180, but they didn't ask for reasons, right? So I'm just going to not going to say anything about the reasons. Okay, so we have 26,57. So what does that tell us? If S is 26,57, that means L here is 26,57. So now P, which is our beta, okay, beta is equal to 180 minus 2 times the 26,57. Okay, again, sum of angles in a triangle. So we're going to say 180 minus 2 times the answer. So I get, and it makes sense that it's an obtuse angle. All right, so this answer does make sense. I get 126,86 degrees. All right, let me just write it out properly. So therefore, LPS is equal to 126,86. Right? Yes. And that concludes question 3. Yes, it does. Righty, let's tackle question 4. So it says in the diagram, the circle with center O has the equation x squared plus y squared is equal to 20. Okay, so then I know then that OD, which is the radius, will be root 20. Okay, and then we have G, which is the center of the larger circle. A common tangent touches the circles at D and F respectively, such that D, which has the coordinates P and -2, lies in the 4th quadrant. Interesting. So let's go ahead and answer the question. So 4.1 says, given that D is P and negative 2 and lies on the smaller circle, show that P is equal to 4. Okay, so yeah, if D there lies on the smaller circle, as we can see, show that P is equal to 4. So what I'm going to do, I'm going to get the distance of OD, which has already been given. And if I then get the distance or use the distance formula to get OD, my only unknown in this case will be P. All right, so let's just go ahead and do it. So the distance OD is equal to the square root, I'm just going to write it out in full, xd minus xo, and all of that is squared, plus yd minus y at the origin, and all of that is rooted. Okay, and then the x coordinate of D, that is P, that of O, that's just 0, so that's just going to be P squared, and then the y coordinate of D, that is negative 2, so negative 2 squared, that's going to be 4. Okay, well, let me just put it like this, negative 2 squared, and that is rooted. Now, what about OD? Remember, we had our equation. They gave us that x squared plus y squared is 20. So somewhere there you would say r squared is actually equal to 20. Therefore, r is root 20, right? And that's the distance OD, which is r actually. So that is root 20. Okay, I have a square root on the left hand side. I have a square root on the right hand side. Basically, I can remove those square roots by squaring both sides. Okay, then I have 20 is equal to P squared plus 4. And then I can say P squared is 20 minus 4, which is 16. And P would be plus minus 4. Now, we know that D is in the fourth quadrant. And in the fourth quadrant, our x coordinate should be positive. So P is ultimately 4. And we have proven or shown it. And that was just 2 marks. But yeah, what I'm realizing with these papers, paper 1, paper 2, they were not bad in terms of difficulty. And because of that, they made the marks quite low. But it's okay. As long as you understand and get as many marks as you can, that's perfect. All right, now it says E is the midpoint of DF. Determine the coordinates of F. Now, do we have the, yeah, we have E. We have E. Okay, so basically E is the midpoint, right? So we will then say E is equal to the x coordinate of D plus the x coordinate of F over 2, y coordinate of D plus y coordinate of F over 2. So E, we have it as 6, 2. And then x coordinate of D, we found it, that's 4. For F, that's what we're looking for. Y coordinate of D is negative 2 plus YF all over 2. All right, so what we're going to do now, we're going to equate all the x's together. So we will say 6 is equal to 4 plus the x coordinate of F divided by 2. And also we know that 2 is equal to negative 2 plus YF over 2. And if I multiply by just getting rid of the denominator, we have 12 is equal to 4 plus XF, and then we have 4 is equal to negative 2 plus YF. So therefore we can say the x coordinate of F is 12 minus 4, which is 8. And the y coordinate of F will be 4 plus 2, which is 6. So ultimately, the coordinates of F is 8 and 6. All right, now 4.3. It says determine the equation of the common tangent DF in the form y is equal to mx plus c. Okay, so we have the coordinates D, E, and F, so you can use any point there. It doesn't matter. All right. Actually, yeah, what I was thinking was actually a lot. What we can do, we can use 2 points to get the equation. All right, I have a video that talks about straight lines and how you can get the equation of a straight line using 2 points. So what I'm going to do, I'm going to use the coordinates D and F. Or you can use D and E, it doesn't matter. Or F and E, it really doesn't matter. It'll give you the same answer. So let me just use D and F. So then the equation is y minus yd all over x minus xd. And then I have yf minus yd over xf minus xd. So the y coordinate of d, let me try to write everything that we know. So we know that d is 4, negative 2. We know E is 6 and 2. And we know F is 8 and 6. We know that OD is root 20. Okay, just putting everything out there. All right, so the y coordinate of D is negative 2. So that's going to be plus 2. And then we have x minus 4. The y coordinate of F is 6. Y coordinate of D is minus 2, so that's going to be plus 2. X coordinate, that's 8. Minus x coordinate, that's 4. All right. So, yeah. We have y plus 2 is equal to x minus 4 multiplied by 6 plus 2, that is 8. 8 minus 4, that's 4. Okay, so y plus 2. 8 divided by 4, that's 2. So I have 2x minus 8. And then now, if I take the 2 to the other side, it will be minus 2. So I have 2x minus 10. And that's the equation of this straight line. Okay, common tangent DF. All right. That was a nice 4 marks. And then now 4.4. So now it says, calculate the value of t. All right. So what do we now know? We know with this straight line, any tangent, okay, first of all, any tangent to a circle is actually perpendicular to the radius. So we have our radius here, FG, okay, and we have our tangent line. So basically, they are perpendicular to one another. So with the equation of df, we know that the gradient here is 2, meaning what will be the gradient of f? Gradient of fg? Gradient of fg will be a half, okay? Negative a half, negative, because, yeah, this is negative a half, because if we take negative a half and we multiply it by 2, we should be getting negative 1, because gradients that are perpendicular, the product is equal to negative 1. All right, so we have our gradient for fg. Now, how are we going to get t? So what we do have, we have point F, we have point G, with t being our unknown, and we have the gradient. So we can use the gradient equation. All right, and say the gradient of fg, is the y coordinate of g minus that of f divided by the x coordinate of g minus the x coordinate of f. So the gradient, we have it as negative a half. Y coordinate of g is 0. Y coordinate of f is 6. The x coordinate for g, that's t. And the x coordinate of f is 8. All right, so then we can say negative a half multiplied by t minus 8 is equal to negative 6. And then if we take the half to the other side, we're basically going to multiply by 2 both sides, and you get rid of that negative as well. So t minus 8 is actually 6 times 2, that would be 12. So now, if we take 8 to the other side, it would be 8 plus 12. which is what? 20. Okay, so that is T, and we can therefore say G is 20 and 0. And whenever you get your answers, just please make sure or just check if they make sense. If D has an x-coordinate of 4, E has an x-coordinate of 6, and F has an x-coordinate of 8, G makes sense that it should be around 20, some high number, okay? So yeah. And then let's see, 4.5. All right. So I thought we had the last question, but we're not. So 4.5, determine the equation of the largest circle in the form ax squared plus by squared plus cx plus dy plus e. All right, so we have our coordinates for G, which is 20 and 0. So we have our center, and do we have the radius? We can actually work it out. We can work out the radius, right? Or was it given to us at some point? No, I don't think so. I think we can actually work out the radius. So let's do that now before we get the equation of the circle. So our radius, which is really the distance of GF, the x-coordinate of G minus that of F. Okay, and that is all squared. So the x-coordinate of G is 20 minus F, that's 8. And you have 0 minus 6. And actually I can get R squared, right? So we can remove that square root on the other side. So 20 minus 8, that's 12. So I have 12 squared here. And I have negative 6 squared. So R squared is equal to 144 plus 36. And R squared, what's 144 plus 36? That is 180. Okay, so the radius there is root 180. But it's all good. We'll leave it at 180. Now let's get the equation of the graph. So we know the equation of the circle. So we know with the circle that's not at the origin, we say x minus a squared plus y minus b squared, with a and b being the center, and that is equal to r squared. So we have x minus 20 squared plus y minus 0 squared is equal to 180. And now let's just take out the bracket. So this x squared minus 40x plus 400, that's 20 squared. If you're not sure, please just check. Okay, 400. And then we have y squared, and that's equal to 180. Now we need to write it in this form that they've given us. I'm going to just take the 180 to the other side. And then we start x squared. And then we get to y squared. And then the coefficient of x, that's minus 40. The coefficient of y, I don't know if they're going to penalize you if you don't put 0y, but let's just do it. And then plus e, so I'm just going to say minus, okay, I have 400 here and I have 180. So 400 minus 180, I have 220. So I'm going to say plus 220, and that is 0. So we've written it, the equation of the largest circle, in that form. Okay, so that wasn't so bad. And now 4.6, it says now, Ooh, the smaller circle must be translated by k units along the x-axis to touch the larger circle internally. Okay, if you have circles touching internally, it can touch internally here. Because it's shifted along the x-axis, I'm just gonna, it can touch internally there. Or if it continues on, it can touch internally there as well. All right. Yeah, now calculate the possible values of k. Remember, this circle was here before, and now it would be shifting there. So they want to know what that value is. That would be k, or what that value is. Okay, that's why it says possible values of k. All right, so I've also covered this section under analytical geometry, where I do talk about circles, if they're touching internally, if they're touching externally, if they are concentric, and if they intersect. Okay, where they intersect and they want these points. I cover all of that, so you can have a look at our playlist for more information. Now, let's see, what are these possible values of k? All right, let's first start with, let me do it like this. Let's first start with this scenario. If it's nearby, and then we'll go to that scenario where it's a bit further. Okay, so what we do there, when circles are touching internally, we calculate the distance between them. So it's actually k, but I'm just going to put d there. So d, for the red one, I'm just going to call it the first scenario. This is 1 and that's 2. So for the first scenario, in order for me to get the distance, firstly, what I'm going to do, I want to get the distance between the bigger circle from the center, right? So I'm going to get the center of the bigger circle and the center of the smaller circle. Okay, so if I call the bigger circle A and the smaller circle B, well, I already named it 1. I'm going to say then I want to get, so the radius then of this bigger circle, which is A, and I'm getting this distance here, so this is D. So I'm going to get the radius of A, and I'm going to subtract by the radius of the first circle, okay, the first scenario. All right, yeah, let me try to redraw it again so that you see what I'm talking about. I have the center over here and I have the center over there, and what I'm calculating now is this distance D, and with that I have the radius, remember, and then I also have this radius. Okay, so for me to get D, I have to take the bigger radius and subtract the smaller radius. All right, and what is the radius of this big circle? We got it to be, remember, radius squared was 180, meaning the radius is actually root 180. So I have root 180 minus the radius of the smaller circle, which is root 20. Okay, remember they told us, r is 20, r squared is 20, so r is root 20. Okay, so that's D, right? I haven't gotten k yet. We're still coming with k. So that's D. So if I calculate that, so we have root 180 minus root 20, and that is 4 root 5. So I have D, which is 4 root 5, but I need to actually get k. So how am I going to get k? K is then going to be this 20 over here. So I know this, the coordinates of the bigger circle. It's 20 and 0. Let me put it there. 20 and 0. Okay. So if I then want the shift for k is going to be, I will then take that distance of 20. Okay, let's actually go to this big circle here. So I'm going to take this 20 because this circle has to move here. Okay, and I need to know what that distance k is. So then I'm going to say this k distance is actually 20 minus d. Okay, I hope you see it. This is 20, right? And I just found, let me use a different colored pen. Okay, so this distance over here, is 20. And what I just found out, if I put the small circle here, I found this distance now from the center to the center as 4 root 5. So my k then is the remainder, you see, which I've indicated over there. So k would be 20 minus d. And I found that d to be 4 root 5. So if I say 20 minus 4 root 5, that's going to be 11,06 units. Okay. All right. Now, how do we get the other one? All right, so we found the first k. Now let's look for the second k. All right, my friend over here is waking up. Let me just pause a bit. Now, when I look at the second portion, which will be my D2, I want to get this D, right, which is from the center of the smaller circle to the center of the big circle. All right, so let's get that D. I'm going to name it D2. Again, there, what I'm going to do, actually, I already have that distance. It still stays the same. It's going to be 4 root 5 because it's the same circles. All right. But how do I get the k there? I would then say k is 20 plus d. Okay? Because now the circle has moved over this side. So basically, I'm going to take 20 and I'm going to go from center to center. So that's why I'm adding now the d. All right, so I have 20 plus 4 root 5. All right, so 20 plus 4 root 5, and that gives me 28,94 units. So those are the possible k values. All right. Yes, possible values of k. So those are the possible k values. It can either be 11,06 units or 28,94 units. And that concludes question 4. All right, question 5. We are halfway there. All right, so it says given sine beta is 1 over 3, where beta is an element of 90 degrees to 270 degrees. So what I normally do when it comes to such an information, especially where they say without using a calculator, determine each of the following. What I would do is draw my triangle, but they gave us that domain for a reason. Okay, so if it's sine, I know that 1 would be y and 3 would be r, your hypotenuse. And if they've given us the domain, or where b is applicable, so if this is 0 degrees, 90, 180, 270, 360. So I know that my triangle can either be here or there because they said it's in between 90 and 270. So it's applicable in those two quadrants. Alright, so let's see. Our hypotenuse is positive. We're expecting that, right? But remember, in this quadrant, y is positive, but in that quadrant, y is negative. And we're seeing here that y is positive. So I'm going to draw my triangle in the second quadrant, okay, just to be safe. So there we have our right angle triangle. We know that our hypotenuse is 3 and y is 1. So let's just get what x is. And in this case, x would be negative. Alright, so if I say x squared is equal to r squared minus y squared, so I know that x is equal to the square root of 3 squared minus 1 squared. 3 squared is 9, okay, minus 1, so I have root 8. Okay, but like I said, it's on the negative x-axis, so actually the answer would be negative root 8. So I know then that this distance over here, it would be negative, this point over here, that would be negative root 8. Okay, so that's the how I normally start these questions. Now we can go and answer with ease because we have all the information that we need. So 5.1.1, without using a calculator, determine each of the following. So, oh yeah, let me put beta over there. So if they want cos beta, remember cos is the adjacent over hypotenuse. So I have negative root 8 over 3. Okay, that's just straightforward. Let's see, 3 marks. And then we have 5.1.2. Now I have sine 2 beta. I have a double angle. So I don't have a double angle on my triangle. So I need to now make it, translate it or transform it to single angles. If there's ever such a way to say it. So I know the identity for sine 2 beta would be 2 sine beta times cos beta. So sine beta I already know, it's 1 over 3. And cos beta, I just solved it in the previous question. I had negative root 8 over 3. Alright, and then when I simplify it, okay, so in the numerator, okay, so there's a negative that's outside. In the numerator, I would have 2 times root 8 all over 9. And I think we can end it there. No need for a calculator. And 5.1.3, we have cos 450 degrees minus beta. Okay, on a Cartesian plane, I would want to know where is 450. So anyway, we have 0, 90, 180, 270, 360. 360 plus 90, that would be 450. Alright, so as such, I can go back and actually say cos 450 minus beta is actually similar to cos 90 minus beta. Alright, and by virtue of that, I would then say cos and 90, it turns into sine beta and it's positive. Alright, so what is sine beta? It's simply a third. And yeah, I think that's it for 5.1. Now 5.2, it says we are given cos to the power 4x plus sine squared x times cos squared x over 1 plus sine x. And now we need to prove the identity. Okay, prove that the left hand side is equal to the right hand side. So let me just write it down. This is 5.2.1. So I have cos to the power 4x plus sine squared x times cos squared x, and that is divided by 1 plus sine x. So basically, I'm going to try to prove that the left hand side is equal to the right hand side, which is 1 minus sine x. Alright, so I'm dealing with the left hand side. And cos to the power 4x. Whew, that is a loaded one. So what I'm going to do rather, I'm going to take out a common factor, which is cos squared x. Okay, so cos squared x, and then I'm left with cos squared x plus sine squared x. Yeah, this is where it gets nice and interesting. If you have that, you start to smile. And then let's make it all over 1 plus sine x, because the denominator I really cannot do much with it. Alright, so cos squared x plus sine squared x, I hope at this point you realize that that is an identity and that is equal to 1. Alright, so then what am I left with? I'm left with cos squared x divided by 1 plus sine x. Now cos squared x, remember the identity sine squared x plus cos squared x is equal to 1. And if I write that identity in terms of cos squared x, I'm actually going to have 1 minus sine squared x. And that would be divided by 1 plus sine x. So I'm starting to see the light. I know in my numerator I have a difference of 2 squares. So I'm just going to factorize it. Sine x. So the other one will be positive, the other one will be negative. And I'm happy because I see that things are going to cancel out. And what cancels out? This cancels. So I'm left with 1 minus sine x, and that is equal to the right hand side, which is awesome, and that's a nice 4 marks. Now let's get to 5.2.2. So it says, for what values of x in the interval from 0 to 360 is that entire sum undefined? Okay, so if it's undefined, according to me, if you have a over b and I want to know what values of this fraction is undefined, I know that I need to ensure that b is not equal to 0, because if b is equal to 0, then it is undefined. Okay, so what am I going to do here? I'm going to take my denominator and say, if I have 1 plus sine x, if that entire sum is equal to 0, then I know it is undefined. Okay, so now I can solve for x. So I know that sine x will be equal to -1. And if I solve for x, I know I'm doing a lot. For those who can do it in quicker steps, because there's only 2 marks, please just write in the comment below. Yeah, I'm just going to do it the long way. Alright, so in a case like this, actually, if you think about it, okay, let's just continue. If I use just 1, I know that x would be 90 degrees. Alright, and this negative, if I were to do the general solution, I know that it would be quadrant 3 and 4, where sine is negative. Alright, but if you think about the the sine graph from 0 to 360, you know that at 1, it's 90 degrees. And at -1, okay, this is 0, 90, 180, 270, 360. So you know at -1, that's where you have 270. Okay, so basically, what values then of x make it undefined? It's basically where x is 90 degrees, or it is also 270 degrees. And if you're not sure, you can go and test. All right, so if you have a fraction there, I'm just going to say 1 over 1 plus sine x, 1 plus sine 90 degrees. Okay, no, I need to put in the entire sum. I can't just say 1 over. I need to put the entire cos to the power 4x. Oh, that's going to take a long time. But basically, where sine is equal to 90 degrees or sine is equal to 270, you would know that that entire sum, 1 plus sine x, actually let's do that. Let's not make a fraction. 1 plus sine 90 degrees, -90 actually. Yeah, this should be -90. It's going to be 0, okay? or where we have sine 270, that's going to be 0. Okay, so it should be negative 90, because if you put sine, if you consider this negative 1, you're going to get negative 90. All right, or 270. Those are the values. Okay, I hope I didn't confuse you there. If I did, please just comment below and I'll try to explain better. Now 5.2.3 says, write down the minimum value of the function defined by that. Okay, that entire sum, I'm not gonna say it out again. All right, so yeah, write down the minimum value for that function. I mean, it's quite loaded, but remember we proved that cos to the power 4x plus sine squared x times cos squared x over 1 plus sine x, that is actually equal to 1 minus sine x. Okay, so basically it's us saying y is equal to 1 minus sine x. Okay, and it's only 2 marks. So in this case, I'm looking at it like I have a graph of negative sine x. Remember, sine x, this is sine x. Okay, if we're going from 0 to 360 degrees. Now, if it is negative sine x, let me use a different color. It's inverted. Negative sine x is like that. Okay, let me try that again so that it's... Okay, that is negative sine x. But now we have 1 minus negative sine x. So if I take negative sine x and I shift it 1 unit up. Okay, let me just increase that. So basically, if this is 1, we go all the way to 2. Okay, and so how would that graph look? Let's use a different color. So I'm starting from 1, then going all the way to 0, and then again back to 1, and then at 2, and then back at 1. Okay, so now my graph looks like that when it is 1 minus sine x. So what are they asking us again? They're saying what is the minimum value for that function. So we can see our maximum value here is 2 and our minimum value here is 0. Okay, so let's go back and write down the answer, and we can say minimum value is actually 0. All right, I hope you understood that. And now 5.3. All right, 5.3. So given that cos A minus B is equal to cos A cos B plus sine A sine B, use the above identity to deduce that sine A minus B is equal to sine A cos B minus cos A sine B. Okay, so this is one of those proofs that you need to know. Again, there's a video in the playlist that I did about all the examinable proofs in grade 12 that you need to know, and it's one of them. All right, and you'll actually find this proof at around 52 minutes in the video. It's quite long. But anyway, let's see. How can we then prove that sine A minus B is equal to sine A cos B minus cos A sine B? How are we going to do that? All right, so let's start. So basically, if we have sine A minus B, we can use the co-ratio, okay, the co-function, and then say we have cos 90 minus A minus B. All right, and from here on, we can then say we have 90 minus A plus B. Okay, and then now what do we want? We actually want a scenario of a cos A minus B situation, or one angle minus another angle. Okay, that's what we want. Let me just put this in clouds just so that you don't take it as part of the sum. So what I'm going to do then, I would say cos, then I take the 90 minus a as my one angle, and I have to have a minus here, okay, and then put b as a minus, because if I have negative and negative, I'll get back to this positive. All right, and then we can go ahead and simplify further. So we can then rewrite it as cos, okay, because the the identity for, or rather the, when you have cos a minus b, it's equal to cos a cos b sine a sine b. So that's what we're going to do now. So we have cos 90 minus a is one angle, minus minus b. So now I'm going to take it as cos cos and sine sine. So I have cos 90 minus a, cos minus b, all right, minus, oh no, actually this time it's going to be a plus, because you know how it works with cos minus there. It's going to turn into a plus once you expand it. All right, so now we're going to have cos cos and sine sine. So sine 90 minus a times sine negative b. And then we can solve it, just simplify it further. So we know that cos 90 minus a, this cos and 90 is going to turn into a sine. All right, so we're just going to have sine a, because 90 minus a is in the first quadrant and cos is positive in the first quadrant. So we have sine a, and then cos of a negative angle is just cos of that angle. Okay, so sine a, cos b, and then I have a plus over there. So sine 90 minus a, the sine and the 90 actually turn into a cos. And because it's in the first quadrant, it's going to be positive. And then we have a negative sine b, because sine of a negative angle is just negative. And then if we now simplify further, removing all brackets, we have sine a cos b minus cos a sine b. And is that what they wanted? Yes, that is exactly what they wanted. So you would have your 3 marks. Okay, just remove that so that it doesn't confuse the marker. And now that's 5.3.1. Now we can go to 5.3.2. So now it says, hence or otherwise, determine the general solution of the equation sine 48 cos x minus cos 48 sine x is equal to cos 2x. Okay, let's just write it down. So I have sine 48 cos x minus cos 48 sine x, which is equal to cos 2x. Alright, so if I simplify this, I go back to sine. Remember, it looks like this, right? So we're going to use that. So I have sine 48 degrees minus x, and that's equal to cos 2x. Okay, so if I need to get the general solution, I need to have either sine and sine or cos and cos. All right, so what would be easy for me? What would be easy for me is actually to change this cos into a sine. Okay, then it becomes sine 90 minus 2x. Okay, so it becomes better. I have sine on the left hand side, sine on the right hand side. Therefore, I can make the angles equal to each other. So I then have 48 minus x is equal to 90 minus 2x. If I take 2x to the other side, it becomes 2x minus x. And if I take 48 to the other side, it's 90 minus 48 degrees. So then ultimately x is equal to 42 degrees, and that is my reference angle. Now what am I dealing with? I'm dealing with sine. Where is sine positive? Sine is positive in quadrant 1 and also in quadrant 2. So quadrant 1, I would say x is equal to 42 degrees plus 360 times k, where k is an element of integer. Okay, so that is my first general solution. And then again in quadrant 2, that is where sine is positive. So I have x is equal to 180 minus 42. Alright, plus 360 times k, where k is an element of integer. And then what is 180 minus 42? That is 138. Alright, so I have x is equal to 138 degrees plus 360 times k, and that is my second general solution. They didn't ask us to solve for x, so we can leave it here. Alright, and that is your 5 marks. And then, is it the last question? Yes. Woo! You see, this section counts a lot. 31 out of 150. That's already like a fifth of the paper. That's 20%. So you want to make sure that you do well in your trigonometry section. So let's do 5.4. Now it says simplify the following to a single trigonometric ratio. Alright, so you have sine 3x plus sine x, and that is divided by cos 2x plus 1. Whew, there's a lot going on there. Okay, so if I see sine 3x, my inclination is to see what can I add together to give me 3? Well, it's just 2 and 1. Okay, so sine, and then I have 2x plus x, and then I leave the sine x, and then in the denominator, for now I think I'm just going to leave it like this until I figure out what to do at the top. So let's just say we're leaving it as cos 2x plus 1. And I'm saying I'm leaving it because cos 2x, the double angle of cos, is a busy one. There are 3 options for cos x, okay? Cos 2x. So let me see first how the numerator works out so that I can judge what to do with the denominator. Alright, so sine 2x plus x, I'm actually going to expand that. So I have sine 2x cos x plus cos 2x sine x. Okay, and I have this sine x as well. And then, yeah, this cos 2x. Okay, let's leave it for now. But in the back of my mind, I should remind myself, what is cos 2x again? It's actually equal to cos squared x minus sine squared x. This is all available in the formula sheet. Or I could have 2 cos squared x minus 1. Or I could have 1 minus 2 sine squared x. Okay, those are my 3 options that I remind myself as I'm doing this sum. Okay, so at the top I have sine 2x. It's easy at least with sine 2x. I only have 1 option for it. So that's going to be 2 sine x cos x times the cos x. And what can I do with this cos 2x? Should I change it? Let me actually use this identity with the 2 cos squared x minus 1. Okay, plus 2 cos squared x minus 1. The danger here is if you choose the wrong option, you're going to have to start the sum again. So I have sine x over there plus sine x. And also in the denominator, I'm going to change it because I have a plus 1 over here and I see that I have a minus 1 there. I'm going to change this cos 2x to 2 cos squared x minus 1 plus 1. And then let's hope for the best. Okay, so here I have 2 sine x cos squared x plus, should I multiply it in or leave it? Let me multiply in the sine. And then I have 2 cos squared x sine x minus sine x plus sine x. Oh, let's just go ahead and see. So the negative 1 and the 1, it cancels. So I'm left with 2 cos squared x. Okay, guys, what am I going to do here? Let's see what's happening at the top. So I can delete these ones, ne? Cancel them out. And then I can probably... Okay. Then what can I do? Oh, actually, yeah, things are working out. Why was I worried? Okay. All right. So these two cancel. But this is the same. I have 2 sine x. And there's the 2. There's the sine x. And then there's a... Oh, yeah. So now I have 4 sine x cos squared x. Right? And the sine x's have cancelled. Right? Yes, they have. Okay. I hope I'm not making any error there. Let me see. 2 sine x cos squared x. 2 cos squared x sine x minus sine x plus sine x. Okay. And in the denominator, I have 2 cos squared x. So I can basically remove this cos squared x, that cos squared x, this 2, and I'm left with a 2. So at the end, my answer would be 2 sine x. We're done. Yeah, we're definitely done. Okay, so we're left with 2 sine x, and that's it. That's my story. And that's it with trigonometry. Question 5, that is. We're not done with trigonometry yet. We are past the halfway mark. Now on to question 6. Trigonometric functions. I love these, and I hope you love them too. If you don't understand, I hope by the end of this answering these questions, it's a bit clearer and you don't have to be scared of them anymore. Okay, so it says in the diagram, the graphs of f of x, that is equal to 2 sine 2x. So we can see that the amplitude has changed, the period has also changed. And the graph of g of x is negative cos x plus 45. So the graph of cos has been inverted and shifted. Has it been shifted to the left or the right? If it's a plus, it has been shifted to the left. Okay. So those are drawn for the interval where x is an element of 0 degrees to 180 degrees. And they give us the coordinate of A, which lies on F. Okay, so let's go ahead and answer. Now it says write down the period of F, which is 1 mark. So if you don't know how to calculate or see what the period is, the equation for period, when it comes to sine and cos, the period for a full wave is 360 degrees, but for tan it is 180, okay? But because for the function of f, we are dealing with sine, so the period will be 360 divided by the coefficient of x. So you can see the coefficient of x is 2, okay? And as such, the period will be 180 degrees. Now it says determine the range of g in the interval from 0 to 180 degrees. So range meaning the y values. Okay, so y, we know that the graph of cos, actually it oscillates between 1 and minus 1. Okay, so now because it has been shifted, it still goes from minus 1 to 1. But in this period, in this domain that they've given us, what I see 1, right? I can't make, let me see, while it loads. So I see that it does start at 1, okay? But on the other side, below, does it go all the way to negative 1? Let's see. So like I said, over here, we can see we have 1. But over here, it doesn't go all the way to -1. -1 probably will be somewhere there. Okay, but it's not at -1. So what is this value? Because now that's our y value, starting from there and it's ending at 1. Actually, what did I write that? Y is an element of starting at some value and it's ending at 1. So how can we determine this value? Well, we can take g of x and substitute 0. So we're going to have negative cos 0 plus 45. Okay, so let's just see. If we have negative cos 45, that's actually negative root 2 over 2. Or if they wanted it in decimal form, we could say it's actually negative 0.71. Okay, you decide what you want to use. All right, so just be careful because like I said, generally the cos function goes from -1 to 1. But with this domain that they've given you, and they've actually explicitly put it there, the range in that interval, you must be very careful. All right. And that is 2 marks. Now 6.3, it says determine the values of x in the interval. X is an element of, okay, from 0 to 180 degrees. Okay, this is where it gets very interesting and where a lot of students struggle. But like I say, hopefully after this you won't struggle with this as much. So basically, if they're saying f of x times g of x is bigger than 0, what they're saying is the y values of f, if you multiply them by the y values of g, what will give you a positive? So if you have a positive y value and a positive y value for both f and g, you're going to get a positive, right? As well, if you have a negative and a negative, that will give you a positive. So that is what we are actually going for. Now, let me just remove all these things that I made. So here, let's just put in, I can see for f, this is positive, right? All the way. I know this is tedious, but this actually helps, especially for visual learners. So here we have positive, but negative over here. So we can see that from 0 all the way to 45, this will not work out because I have positive values and I have negative values, and positive times negative gives me negative. But from 45, okay, all the way to 90, I see that I have positive all throughout, so this will give me a value bigger than 0, so that's great. But now from 90 onwards, I have negative, and I have for f, and I have positive for g, so that will not work out. So therefore, my answer then lies in between 45 degrees, and remember they didn't say bigger than or equal to, it's just, the inequality sign. So x is going to be in between 45 degrees and in between 90 degrees. And that is the answer. Okay. Now let's go to 6.3.2. So it says, determine the values of x, where now we have the function of f plus 1 being smaller or equal to 0. Okay, so let me just remove all these markings over here so that we can have a look at it quite properly. So now f of x plus 1, where it's smaller and equal to 0. What if I then said f of x is smaller and equal to -1? And I'm looking for the y values of f that are below and equal to -1. So if I then put a line across -1, I'm basically looking at these values over here. Okay, because that is where the y values of f of x are smaller than -1, smaller and equal to. All right, let me just remove this line. So basically, and this is why they gave us the value of a, all right, they were helping us. And so basically, from a, okay, from a all the way to this value over here, this is where the x values are applicable. Okay, so x in this case, again, it's in between 105 degrees. And how do I get this other value over here? So what I'm going to do is I'm going to ask myself, between 90 and 105, how many degrees are there? So 105 minus 90, that's 15 degrees. So this is 15 degrees. And because this graph is really symmetrical, I know that this will also be 15 degrees. So now what is 180 minus 15 degrees? That is 165. So I know this point over here is at 165. So x is in between 105 degrees and also 165 degrees. Okay, so I hope that makes sense. And 6.4. So now it says another graph P is defined as P being negative f of x. Okay, let me erase everything over here. So this is our f of x, right? Now, how would negative f of x look? Well, it's just the inverse. So we're going to have 0 there, -2, 90, +2, 180. Okay, so this is how the graph of P would look. So now they're saying another graph P is defined as that, right? And then D, which has an x value and -1, remember this is where -1 is. So yeah, it lies on P. Now it says determine the value or values of K in that interval between 0 and 180. So K can be here or K can be there, all right? And because I'm looking at this graph, I'm not going to calculate it in a certain way. I'm going to answer this question graphically. Okay, so we know that P is actually negative of f, which is -2 sine 2x, all right? So I can see K actually has two values because they said 1 or 2 values, all right? So I know from the previous question there that actually this space here at -1 is actually 15 degrees. And also the space here is 15 degrees. So I know that K can either be 15 degrees or K can be 90 minus 15. Just the same way we got the 165, right? The 165 we got by saying 180 minus 15 degrees. So 90 minus 15, okay, 90 minus 10 is 80, minus 5 should be 75. So there we go. K is either 15 degrees or 75 degrees. Okay, so you should be careful. Every time they say determine the value and they put in brackets values, you might have more than one answer. Okay, all right. Otherwise, you could have taken the equation for -2 sine 2x and you could have substituted the value of -1 and solved for x. Okay, but I feel like that's a long way. Or maybe that's what you should have done. So you have D, so you have K, -1, and you have -2 sine 2k. And basically you'd be solving it. So you'd have a half is equal to sine 2k. So basically you'd say 2k is equal to arc sine a half. And what would be the inverse or shift sine? 0.5, so that's 30. So that's 30 degrees and you have 2k. So k would be 15 degrees. But that gives you only one answer. You can see by the sketch that there are actually two answers here. So just be careful, okay? Yeah. And that's 6.4. Now the last question for 2 marks. 6.5, it says graph H is obtained when G is translated 45 degrees to the left. Okay, so what is G again? Just remind ourselves. G has already been translated to the left because we have a plus. And now you're translating it again to the left. So it says determine the equation of H. So H, if it's translated to the left, it would be plus another 45 degrees. So therefore we have negative cos x plus 90 degrees. Now I'm not done reading this question. I should learn to finish reading before I start talking. So it says write your answer in its simplest form. If it is in its simplest form, as soon as you see cos and inside the bracket there's a 90, then you know something is going to happen. So let's just put it like this, 90 plus x. So this cos and this 90 is going to give us sine x. And because it's 90 plus x, 90 is there, right? 90 plus x is in this quadrant over here. And cos in that quadrant is negative. So I have a negative sine x and there's already a negative outside. So in its simplest form, h of x is actually sine x. Okay, and that's it for trigonometric functions. Question 7. Alright, so this is the last portion of trigonometry. And it says, in the diagram, S, T, and K lie in the same horizontal plane. RS is a vertical tower. The angle of depression from R to K is beta. And then angle S between T and K is alpha. TS is equal to P meters and the area of triangle STK is Q squared meters. Alright, so the way I normally do these questions or question 7 is I separate the triangles to see what I know and what I don't know. Okay, so let's just start there. I'm going to start first with triangle R, S, and T. Okay, so we know that ST is P. And RS, we don't know anything about it, so that's fine. Then I'm going to go to the next triangle. Okay, so that is also R, S, and then we have K. And they told us the angle of depression there, which is beta. Okay, and I think that's all we know. And then we have the triangle at the bottom. I'm going to just put it there. So in the horizontal plane, which is T, S, K. Okay, we know that TS is P units, P meters. SK, we don't know anything about it. We know S is alpha. And we know that the area of this triangle is actually Q meters squared. There is another triangle, but I doubt we're going to use it. But let's just draw it for the sake of consistency. It's RTK. And there we don't really have anything. So yeah. Let's see what the questions are saying. Now 7.1. It says show that the length of determine the length of SK in terms of P, Q, and alpha. Okay, so we see SK. We find it here and we also find it there. Alright, if I look at triangle RSK, I don't have much information. And my angle there is in terms of beta, so that wouldn't help me. So if I look at the triangle STK, that will actually help me because I have alpha, I have P, and I have Q. Alright, so that is not debatable. So now and also I have the area. Okay, so I can say the area of triangle STK is actually equal to, and we can go to the end to see the formula sheet. Yeah, where's the formula sheet? The area is half AB sine C. Okay, half AB sine C. Okay, but we need to relate it now to our triangle. And what we can say just by looking at the sketch that we did, what would be our AB? I would take ST as my A and SK, because we're looking for SK, right? ST, SK, and then sine. So if we've taken ST and we've taken SK, then it's going to be sine S. Alright, so let's go back. We have our formula, so that's cool. Okay. So yeah, we need to determine the length of SK. So we know the area, they told us that the area is Q. So we can put that over there. And then we have half, so ST, that's P. SK is what we're looking for. And sine S, that's pretty much sine alpha. Alright, so that's great. So now I can put everything in terms of SK. Okay, so let me just take the half to the other side. I have 2Q. And then we just say SK. And we have P sine alpha. So now I know that SK would be 2Q all over P sine alpha. Alright, so that is it for 7.1. We can actually write down, once you have the information, just populate it in your sketches. It can make life a little bit easy. So we have 2Q over P sine alpha. Same here, but I'm not going to write that down. We have it. So yeah, same here. So 7.2 says, show that RS is 2Q tan beta over P sine alpha. Okay, RS, where is that? It's either in this triangle or that triangle, but because I don't know anything about triangle TRS, I'm going to go with triangle RSK. And they are asking RS, right? And I'm seeing beta there, so that confirms it even more. So tan beta, I know that whenever I'm looking at this question, I'm going to start by saying, what is tan beta? So tan beta, remember tan is opposite over adjacent, so it's RS over SK. Okay, and then I'm gonna write everything in terms of RS, which is basically SK times tan beta, and we already determined what SK is. And this is the moment where now you can actually see whether your SK was correct or incorrect. So SK, we had 2Q over P sine alpha times tan beta. And do you see, if we write everything on the numerator, we have 2Q tan beta, and that is divided by P sine alpha. And that is RS. We have shown that. Okay, so we are good. And the last question for question 7 is 7.3. It says calculate the size of alpha. Okay, if alpha is smaller than 90 degrees and RS is 70 meters, P is 80, Q is 2,500 meters squared, and beta is 42 degrees. Okay, so we're looking for alpha. So what I would say, we have our equation in terms of RS. I am going to take, okay, let's just rewrite it. So RS is equal to 2Q tan beta over P sine alpha. I'm going to take sine alpha to the other side. And I'm going to also take RS to the other side. So I have 2Q tan beta divided by P times RS. Okay. And then now we can plug in, actually, no, let's get alpha because we want the size of alpha. So it will be arc sine, all of that, 2Q tan beta over P times RS. Okay, now we can put everything together. Or substitute. So in the place of Q, we have 2,500. So 2 times 2,500 times 10. And beta is 42 degrees. Divided by P is 80 times RS, and RS is 70. Alright, so now we can calculate. So we have shift sign, and we have a whole lot going on here. So we have a fraction, 2 times 2,500 times 10, 42. No, it is 42 degrees, yes. Divided by 80 times 70. And we have an answer of, it is thinking. Maybe I'm loading this question. I'm loading this calculator. Okay, so we have an answer then of 53,51 degrees. And they did say that alpha has to be smaller than 90 degrees. And ladies and gents, we are done with question 7. 3 questions left, 8, 9, and 10. Okay, now let's look at question 8. So 8.1. In the diagram, O is the center of the circle. Okay, so without even going far, I can see you need to prove the theorem which says that this angle over here, O, is actually twice that angle over there. Alright, I am not going to prove this. I have a video in the playlist, the maths playlist. I'll try to put the link below. And I have covered all the examinable proofs in matric, so please check that out. I don't want to repeat myself too much. So let's move on to question 8.2. All right. Okay. So yeah, you can go have a look at the maths playlist. It's the last video. It's like over 2 hours where I go through every proof from paper 1 to paper 2. So you are sorted. Okay. Anyway, 8.2, it says in the diagram, O is the center of the circle, and ABCD is a cyclic quad. OB as well as OD are drawn. So there is a lot that is happening over here. And now it says O1 is 4x plus 100 and C is x plus 34. Calculate, giving reasons, the size of x for 5 marks. So let's just put in all the information that we can. All right. O1, they've told us it's 4x plus 100. Oh, my pen is thick. Yeah, no, this is not gonna work. This is too thick. Okay, let's reduce the thickness a bit and see. Okay, 4x, yeah, much better. 4x plus 100 degrees, that is O1. And then C is x plus 34. All right, and we have, what is it? Center, right? So if I see, I don't know if you remember, if you have something like this, okay, you know that the angle here, the reflex angle, is actually twice this angle. Okay, so if you have that, then yeah, you can do some things. So in this case, O2 would be twice C. All right, so now in order for us to get O2, we can say that O1 plus O2 is equal to 360 degrees. All right, and we can say angles around a point. I forgot the actual reason. Or you could say sum of angles in a revolution are equal to 360 degrees. Okay, I'll use that. Sum of angles in a revolution equal to 360 degrees. So I have O1, which is 4x plus 100. So O2 will be 360 minus O1, okay, which is 360 minus 4x plus 100. And if I remove the bracket, it's minus 4x minus 100 degrees. And then if I take 360 minus 100, that will be 260 minus 4x. Okay, so that is O2. And O2 is actually equal to twice C. Okay, and we've established that O2 is 260 minus 4x. Oh, we need to give a reason. Well, O2 is equal to 2C, and that is the reason that we had before, where we had to prove that TOP is equal to 2 times TKP. Okay, so what you would write there in terms of your reasoning, with O2 being equal to 2C, angle at the center, yeah, you can actually leave it at angle at the center, but you can explain. Angle at the center is twice the angle at the circumference. All right, so now we have 260 minus 4x, and then 2 times C. What is C again? It is x plus 34. All right, so we have 260 minus 4x is equal to 2x plus, what is 34 times 2? 68. Okay, if I take 4x to the other side, I actually have 6x. And if I take 68 to the other side, what is 260 minus 68? That is 192. So x at the end is 192 divided by 6. 92 degrees divided by 6. So 192 divided by 6 is actually 32 degrees. Okay, so that is the value for x. And that is for 5 marks. I think it was a reasonable question. Okay, and now we get to 8.3. So 8.3, it says in the diagram, O is the center of the larger circle. Okay, and then OB is a diameter of the smaller circle. Okay, as soon as you hear diameter, that should tell you something. The angle subtended by the diameter is actually 90 degrees. Okay, then chord AB of the larger circle intersects the smaller circle at M and B. Now they're saying write down the size of OMB and provide a reason for it. Okay, that's what we were saying. So M is 90 degrees, right? And what's the reason? Well, angle subtended by diameter. I know there's a shorter reason, but this is what I remember. Angle subtended by diameter is equal to 90 degrees. Okay, and then 8.3.2. So we can then put there that M is 90 degrees. Now, if AB is equal to root 300 units and OM is 5 units. Okay, so this is 5 units and that is root 300. Calculate, giving reasons, the length of OB. So we need this length. All right. So, you know the line coming from the center to a chord, that actually divides the chord equally. Okay. So in that case then, AM would be equal to MB, which is actually equal to root 300 times a half. Okay, and what reason would you put there? Line from center to chord, something like that. Line from center to chord. You can continue and say the line from the center to a chord actually bisects the chord. Okay, so we now know that AM is equal to MB, which is half of root 300. So now I have my right angle triangle. Okay, and I have did they say 5 units or 5 meters? It's 5 units. So that's OMB. So OM is 5 units, and then MB is root 300 over 2. And we're looking for OB. So we can then use Pythagoras by saying OB squared is equal to OM squared plus MB squared. And OM is 5, so that's 5 squared. So if I want OB, that's going to be the root of the entire sum, but let's just do OM. That's 5 squared, and MB is root 300 over 2 squared, and all of that is under a square root. So we can then use our calculator and check what that value is. So we have 5 squared plus root 300 all over 2. So OB is 10 units. Okay, that was nice and easy. All right, and then, and that's the end of question 8. Second last question, question 9. All right, so it says in the diagram, ABCD is a parallelogram with AB being equal to 14 units. Okay, so as we are reading this, just write down the information. So AB is 14 units, and then AD is produced to E such that AD to DE is 4 to 3. So that's the ratio, right? So AD is about 4x and DE is about 3x. Okay, EB intersects DC in F. All right, and then they tell us that EB is 21 units. So we have 21 units over there. Okay, cool. And what I see, because they told us that ABCD is a parallelogram, we know that the opposite sides of a parallelogram are parallel, which helps us in this case. So now, 9.1, it says calculate with reasons the length of FB. Okay, I'm going to redraw this, but not exactly as they have drawn it. I just want to draw it in a way that's, simple. So I have E, D, A, and B, F. And I know these lines are parallel. Okay, we've been told. And now we're looking for the length of FB. So what I'm going to do then, I'm going to say FB over EB is equal to AD over AE. And I can do this because I have a triangle with sides that are parallel. Okay, so then I'm going to say this is due to the proportionality theorem. And when I state that this is the proportionality theorem, I need to say which sides are parallel. So DF is parallel to AB. Or you could say DC is parallel to AB, doesn't matter. All right, so now I can even put this in terms of FB and say AD over AE multiplied by EB. I already know what AD is in terms of x. That's 4x. Not 47, 4x. And AE is the sum of AD and DE, so that's going to be 7x. And then EB, I already know that's 21 units. Okay, so the x's will cancel out. So I have 4 over 7 times 21. And remember, 21 is like 3 times 7. So the 7s would cancel out, and I'm left with 4 times 3, which then is 12. So FB is 12 units. And whatever I find, I'm going to populate. So I have FB as 12 units, meaning EF 21 minus 12, that would be 9. Okay, so I have filled in, what I can. Alright, so we can go over to 9.2. So it says, prove with reasons that triangle EDF is similar to triangle EAB. Alright, so triangle EDF, and then triangle EAB. So EDF is like, if you look at our sketch previously, EDF is the top part, and EAB is like the full triangle, the bigger one. Alright, so what I'm going to do then, I'm just going to draw them separately. So I have EDF. Okay, I have 3x over there. I have 9. And then the bigger triangle, which is EAB. I have 14 over there. EB, that's 21. And EA, that is what, 7x. Okay, now let's see how we're going to prove similarity. Well, firstly, we have E, that's the common angle. So we're going to say E is equal to E. Why? Because that's the common angle. Okay, another thing that I also didn't mention is whenever they give you which triangles to show that they're similar, the order in which they write the letters, please, that is important to maintain it. So basically, we're trying to prove that E is equal to E, D is equal to A, and that F is equal to B. We are maintaining that order. If you change it, it changes everything. So now let's see, can we show that D is actually equal to A? Can we show it? Yeah, we can. Because we have parallel lines, we can say that D is equal to A, and the reason would be corresponding angles. Okay, so corresponding angles. And which sides are parallel? Again, we're going to say DF is parallel to AB. DF parallel to AB. Alright, so we've proved 2. And then the last angle, which is F and B. Well, if you've already proved 2, the last one, we just say they're equal because sum of angles in a triangle, that's equal to 180 degrees. Alright, so yeah, you can leave it at that. Or you really can prove it. So let's see, why would F be equal to B? Again, corresponding angles. Okay, because of the parallel lines. So it would be the same reasons as we have shown before. Corresponding angles, and we have that DF is parallel to AB, or DC is parallel to AB. So it's basically the same reason. So I would just leave it at that. And because of that, we can then say, therefore, triangle EDF is actually similar to triangle EAB. And because we've proved showing angles, or showing that the angles are equal, our reason can be angle, angle, angle. Okay, that's cool. And now 9.3, it says calculate with reasons the length of FC. Alright, so we have AB, AB is actually equal to DC. Remember, we're dealing with a parallelogram. Okay, sorry about that. So what we can do here, all right, still looking at our triangle, EDF as well as EAB. If we know the length of DF, then we can say 14 minus DF is actually FC. Okay, so basically let's start off by saying that DC is equal to AB, right, which is equal to 14 units. All right, and that is because opposite sides in a parallelogram, opposite sides are equal in length. All right, so then if we say DF plus FC is equal to DC, we can then say FC is equal to DC minus DF. So the whole point here is to get DF. And because in the previous question we showed that triangle EDF is similar to triangle EAB, we can then say ED over EA is equal to DF over AB, which is equal to EF over EB. That's why I said it's quite important how you write it. All right, so what do we know? Do we know ED? Yes, that's 3x. Do we know EA? Yes, that is 7x. Do we know DF? No, that's what we're looking for. And then AB, yes, that is 14. So we're not even going to bother with EF and EB because we don't really need it, right? Or maybe wait, before I actually write it off, but I don't think we need it. So EF is 9, EB is 21. So I can decide, I can either, because my unknown is with DF, I can either use this or I can either use that to get DF. It's not a problem. Okay, but let's see, will it give us the same answer? So if I say DF over 14 is equal to 9 over 21, and I say DF is actually 9 over 21 times 14. Okay, let's see what that would be equal to. So I have 9 over 21 multiplied by 14, and I get 6. So DF is actually 6 units. Would it have worked if I said DF over 14 is equal to 3x over 7? It should work. So then we have 3 over 7 times 14. Let's see now. Yeah, it will work. Actually, I just saw, but we're just checking, right? Yeah, so it is 6 units. So either way, you could have used ED over EA or EF over EB. So now we have DF. We can go back to our sum to say that FC, which is what we're looking for, FC is equal to DC minus DF. Right? That's how we wrote it. Yes. And we know that DC is 14. Yes, because it's equal to AB. 14 minus 6. So we have 8 units. Alright, so FC is 8 units, and we are we done with question 9? Is it? Yes, it was just 9 marks. Yeah, we're done with question 9. And we've reached the final question. Question 10. In the diagram, PQRS is a cyclic quad such that PQ is equal to PR. Okay, let's first see where PQRS is. So I can see R. There's R and S, P, and Q. And they're telling us that PQ is equal to PR. Okay, no, PQRS is a cyclic quad. Yes, PQRS. And they tell us that PR is equal to PQ. So we have like, let me just highlight it. No, that didn't work out well. Let's just use a different colored pen. So now we have that PR is equal to QR. Okay, so they're equal. So if PQ is equal to PR, it means that R3 is equal to Q1 and Q2. Okay, that's something that I can write for myself. I don't know where I'm going to need this, but yeah, R3 is equal to Q1 plus Q2. Or instead of writing it like that, I could say it's equal to RQP. Okay, so R3 is equal to RQP. Yes. And then now it says the tangents to the circle through P and R meet at QS. Okay, let me just take a little break. Actually, I was thinking before I move on, getting back to the fact that PQRS is a cyclic quad, we have external angles to a cyclic quad. Okay, let me go back to my green pen. So I have here with these external angles. Oh, I forgot to write here equal sides, equal angles. I don't know if I'm going to need it, but yeah. And then now I see that S3 actually is equal. This is me. When I do Euclidean, as I read the questions, I just want to make sure I'm writing down what I can see so that when it's time to answer questions, it becomes easy. Okay, so just bear with me. So S3 as an external angle in a cyclic quad, I can see that it is equal to RQP. Okay, and that is just the reason, external angle of a cyclic quad. And there's also another. Is there another external angle? Yes, there is. So it's right there. It's actually S6. Same thing. It's also equal to RQP, external angle of a cyclic quad. Okay, so I think I'm done with the cyclic quad theories. For now, the external angles, I'm not going to deal with the opposite angles that are supplementary. I'll leave that out for now. And also, oh yeah, actually back at the cyclic quad, I know that S4 is equal to R3. That's something that I can also note. All right. And yeah, so it's equal to R3. What else do I see? Also, R2 is equal to Q2. What else? So I'm looking at angles subtended by the same chord. All right. Also, I can see that P2 is equal to Q1. Yeah, there's quite a lot. There really is quite a lot. Even S5, S5 can be equal to P3. Okay, so there is a lot. And that's basically angles subtended by the same chord. Okay. Yeah, so angles subtended by the same chord. So that's it with the cyclic quad. Then it says the tangents to the circle through P and R meet QS. Okay, produced at A. Okay, so now if you have tangent lines, remember, let me use a different colored pen. I hope you know that in this case, AR will be equal to AP. All right. And also, if I look at triangle, RAP, okay, so AR is going to be equal to AP. I'll deal with the reasons later. And I know that R1 plus R2, so again in triangle RAP, I know that R is equal to P. Okay, because now we have an isosceles triangle. Okay, so we're done with the tangents, and then it says PS is produced to meet tangent AR at C, and PR and QS intersect at M. Okay, there is M if you couldn't see it. All right, now we can finally answer questions. So 10.1, prove giving reasons that S3 is equal to S4. Okay, do we say anything about S3 over here? Yes, we did. We said that S3 is equal to Q, all right, in RQP. Okay, so we can start there. You can start there that S3 is equal to RQP. So I can do this now, but you would have to rewrite it. So I'm going to say copy and paste. All right, and we have our reason. And what else? So if S3 is equal to that external angle of a cyclic quad, then I can say RQP. What did I say here? S4 is equal to R3. How do I relate R3 to RQP? Okay, let's keep looking. Now, what can I say about Q? Oh yeah, at the beginning I said that R3 is actually equal to RQP. Okay, so let's say RQP is equal to R3. Let me also just take that. Okay. I paste that. Equal sides, equal angles. All right. And now that I've said that, let's see. How can I deal with this R3? Did I say anything about S4? Yes, I said S4 is equal to R3. Okay, I did. I was already getting lost in my work. Okay, so there we go. In 3 steps. Yeah. S4 is equal to R3. Okay, so we've shown, let me just remove everything here because it's such a mess. Okay. Yeah, so basically we have said S3, let me also change the thickness. Okay, we said S3, this external, is equal to this Q, right? RQP. And then we also said RQP is equal to R3, okay, because that was given, equal sides, equal angles. They told us that PQ is equal to PR. Okay, we can add that, PQ equal to PR. And then we also saw that S4 is equal to R3, right? Which is angle subtended by the same chord, and that chord PQ. Okay, let's write that down so that the marker knows which chord we're talking about. Chord PQ. So then ultimately, therefore, we can then conclude that S3 is equal to S4. Whew, I know. All right, 10.2. So it says SM proof giving reasons that SMRC is a cyclic quad. All right, so where's S? There's S. SMRC. So it's like there's a circle here. Okay, and we need to prove that this is a cyclic quad. Now there are 3 ways, and you can choose one of them to prove. Okay, so if angles are coming from the same chord or angles subtended by the same chord, that's one of the ways. Or you can go with external angle in a cyclic quad is equal to the interior opposite angle. Or you can prove that angles are supplementary. Okay, so looking at the first option, I can't see any chord that I can use to support that, so I'm not going to go with this. if I look at the external angles, I can get that external angle, or that one, this one, or that one, or that one, or this one. So I think I have a better chance using the external angle of a cyclic quad. And then when I look at the internal angles, I mean, I would have to prove that C2 is equal to M1. And I haven't said anything about C2, nor have I said anything about M1. So I think I'm going to just shoot myself in the foot for using that. Okay. So, yeah. Let's see what we can then do. All right. So, where I can start, remember, actually, let me remove everything. Remember, we have this tangent line, AR, and that's equal to AP, right? Meaning R1 and R2 is equal to P1 and P2. I think let's just start there. So if I say ARP is actually equal to APR, okay? And that is due to equal sides, equal angles. Okay, it's a isosceles triangle, basically. All right. And then, if I then again look at, okay. How can we do this? Which external side? Let me just draw this in again. Let me use a different colored pen and make it a bit lighter. Okay. So if I go, this is my cyclic quad that I want to prove. What would be equal to R in the cyclic quad? Okay, so basically I would have to then show that S4 is equal to R. I would have to, I'm gonna use the external, no. If I'm going to use the external angle, maybe I have to prove that S4 is equal to R. Let's just work with that goal. S4 is equal to R. Okay, R1 plus R2. Or I could say ARP. Okay, so that I have some direction, I know what I'm working towards. Okay. Yeah, my little best friend there is making some noise, but let's bear with me. Please just bear with me. So now I've shown that R is equal to P. Now how can I use P? Okay, if I say P is equal to Q, do you see we have a triangle over here? And with this triangle we also have a tangent line. So then I can say APR is actually equal to Q1 plus Q2, or RQP. Okay, and that's basically the tan chord theorem. Alright, so I can use that. That's the tan chord tan chord theorem. Okay, but what does that tell me? Now I know that S3 was equal to Q. Okay, I think I had proved that before. S3 is equal to RQP. Yes, previously proved. Okay, so S3 is equal to Q, and we know that S3 is equal to S4. S4. Okay, that was also previously proved. And now I can say that S4 is then equal to ARP. Woo. Which is what we were trying to show here, right? So S4 is equal to ARP. All right, now let's get back to everything that I've mentioned over here. If I'm saying S4, there's S4. Okay, I'm trying to look at this and show that this is the external, this is the cyclic quad, sorry, we're saying S4 is equal to ARP. Okay, so therefore we can then conclude that SMRC is a cyclic quad. Cyclic quad, because S4 is equal to ARP, and that's the external angle of cyclic quad. Okay, oh my gosh, 4 marks, but we did it. Okay, 10.3. RP is a tangent to the circle passing through P, S, and A at P. Alright, so this is S, P, S, A. There's a circle and then we have a tangent. Okay, so if I do something like this and we have a circle, so the circle is quite big. Alright, yeah, it goes all the way. That's the circle. So now we need to prove that RP is a tangent. Alright, and if I look at what we have inside, we have a triangle. So here it's giving me 10 chord vibes. And the way of proving with this 10 chord, I can say that I need to prove that P2 is equal to A2. So if I can just prove that P2 is equal to A2, then we are sorted. Alright, so how am I going to start with this thing? So I was thinking using the strategy. So let's just say, let's just give P2 a variable. So let X equal to P2, or let P2 equal to X. Okay. And then as such, we need to show that A2 is equal to X. Okay. So if P2 is equal to X, and also let's just say P1 plus P2, that is equal to Y. So the entire angle here, make it equal to Y. All right. And what am I trying to achieve here? Okay, so I wanted to look at this big triangle. If I have a look at A, Q, P. All right. Try to see if A2 can be equal to X. That's what I'm trying to work towards. So I need to know what P3 is. All right. Before I do that, because I don't know what P4 is, let's look at P4. Have we said anything about P4? P4, in actual fact, that would be equal to R3. If I look at this triangle RPQ, okay, in this bigger circle. Well, for now it's the middle circle, it's not that big anymore. So P4 will be equal to R3. All right, and that is the 10 chord theorem. Okay, so 10 chord theorem, P4 is equal to R3, and we know that R3 is actually equal to RQP. Okay, and remember they told us that PR is equal to PQ. Okay, so R3 is equal to RQP. I think I've written it somewhere. Yes, equal sides, equal angles. So that was already proved. Okay, so geez, so what? So I know what R3 is, which is equal to RQP, and I know I was looking for P1, sorry, P4. Yes, I was looking for P4. So basically P4, Yeah, now I'm lost in my calculation. Okay, so P2 is equal to X. I said P1 and P2 is Y. Therefore, I can conclude that P1 is actually Y minus X. Okay, if I take P2 as X and P2 to the other side, P1 is Y minus X. And then I said P4 is equal to R3 and R3 is equal to Q, and Q is equal to P1 and P2. Okay, this Q is equal to, yeah, there's a lot going on here. Let me just subtract all of this. Okay. All right, if I look at Q, Q1, Q2 is equal to P1, P2. Yes, so also if I say P4 is equal to R3, then P1 and P2, P1 plus P2, that is equal to RQP. Okay, and we said that P1 and P2 is equal to Y. All right, I think I'm getting my feet again. So Y is equal to RQP. Okay. All right, yeah, let me just put it next to it there. To say P1 plus P2, we said it's Y. Okay. Now we have P4, right? Which is Y, basically. All right, I said I want P3. That's why I'm doing all of this. Okay, so basically P1 plus P2 plus P3 plus P4 is equal to 180 degrees because that's angles in a straight line. I know that P1 is equal to Y minus X, but let's just say P1 and P2, that is Y. P3 is what I really want at this moment. And then P4, we know that it's Y. Okay, that's 180. So at the end, P3, that will be equal to 180 minus 2Y. Okay, why is that significant? Let's just erase everything here so that we can see what's going on. Okay, I said I want to focus on this big triangle over here. I know that, okay, now let's just check what P1 plus P2 plus P3 is going to be. If I can get this angle and if I can get Q2, then I can ultimately get A2. Okay, so anyway, let's look at triangle PSQ. All right, which is this one over here. Let's just see what we can do with PSQ. So in triangle PSQ, I know that, okay, let me use a different color. This triangle PSQ, so that I can get what Q2 is. Okay, so I already have P2 plus P3, so that's fine. But what would S4 be equal to? And what would Q2 be equal to? All right, so I know using the tan chord theorem that P1, P1 is actually equal to Q2. Okay. All right, that's the tan chord theorem. Okay, and I said that P1 is actually equal to Y minus X. So I'm going to say tan chord theorem. Okay, so therefore Q2 is equal to Y minus X. All right, so I have Q2, I have P1, P2, P3. Now I can get A2. Okay, so now looking at the big triangle now, in triangle APQ, A2 plus P plus Q2. That should be equal to 180 degrees because that's the sum of angles in a triangle. So A2 is what I'm looking for. So A2 will be equal to 180 minus P. Let me not put it in brackets. So minus P minus Q. Okay, specifically Q2. So this P that I'm talking about, if I just remove this, okay. So P, I'm referring to P1, P2, and P3, actually. And Q, I'm referring to Q2. Now, what is P1 and P2 and P3? Ooh. P1 is Y minus X. P2, we said it's X. Remember, we gave it X. And P3, we said is 180 minus 2Y. And then Q2, we said it's Y minus X. Now we have 180 degrees minus. So this minus X and that X, they cancel. Y minus 2Y, I have a negative Y. And I have plus 180 degrees minus Y minus X. Now let's take out the brackets. So we have 180 plus Y minus 180 minus Y minus X. So the 180 cancels, the Y's cancel. Geez, then I have a negative X. Oh, minus Q2. So it's minus Y plus X. Okay, so A2 is finally equal to X. Oh my word, guys. Oh no, this is like too much. This is too much. If anyone has a shorter way of doing this, please just, yeah, help out the learners, because I feel like the way I did it was very complicated. So because A2 is equal to X, we know that it's equal to P2. Yeah? Then we can conclude and say, therefore, RP is indeed a tangent passing through P, S, and A at P. Okay, and we use that. We say that because A2, yeah, because we're saying A2 is equal to P2. Okay, remember, this was the tangent line, and this was the circle. Yeah, so basically P2 is equal to A2, which we made X. Okay, 10 chord theorem. Yeah, I have to admit question 10 was tough. Just when you think this paper was doable, question 10 came and was like, I still want to test you. And that's it, ladies and gents. We are done with maths paper 2.